title of the presentation is Smart Metering, and then I was reading the title, why do I use smart? Because I really hate the word when we talk about meters and use the word smart meter, because at the end the meters are not smart anyway. So, but basically what I will try to do during this presentation is to talk about two things. To talk about the hardware and the software. Because one of the things that we have been talking about during these previous talks is that we all agree that we need more data. Most of the things that, or the model that we are developing or you are developing, it has to do with maybe end-use disaggregation or energy uses or understanding the behavior of the customers. And some of the times we are lacking of longer time series or like more detailed data that can help us in producing the model. So basically what I'm trying to do in this presentation, of course, is not solve all the problems because I will not be able to do it, but only just to tell you my experience, and if that experience can help you, but I think it will be helpful. So I will talk about two things. First of all, the hardware, which kind of hardware you can use, because of course, at the end of the day, what we can analyze is what we register. If we are not registering water consumption properly, all the models that we will do will not be right. So the first thing we have to worry about is how we measure water consumption. And we are trying to do it the best possible way we can. When I go with the presentation, you will say, why do you need so much? At the end, I'm not saying that you need to go for the resolution I'm talking about or the level of detail that I'm talking about in this presentation, because at the end one have to sit down and say, okay, what am I trying to do? What level of detail I have? Because of course, more detail, higher cost. That's obvious. So what I'm saying here is that the new technology is allowing us to have more detailed data for a longer period of time. And then, after that, we can decide what level of detail we need to have for the objective of our study. One of the things I'm trying to do also is to develop a set of data that can be used to calibrate, for example, all the models for automatic end-use disaggregation, because most of the time, for example, we are relying in the data sets that come from the studies from Aquacraft. And how do you know that the results are correct? And if you develop an automatic disaggregation tool that is using that model as a reference, all that comes after that, it's wrong. So the idea would be to try to have a data set that help us in developing those models. So when I'm like talking about, okay, we have to measure water consumption with such level of detail, I'm thinking about developing that database. Of course, then each one will do whatever they need to do. The other thing, for a study that we are conducting in Saudi Arabia, we developed a software tool that is helping us to do the disaggregation, water and use disaggregation, coming from the flow traces that we determine with the hardware that we are using or that you can be using. The main difference with respect to, for example, the Aquacraft tool is that our tool is a web-based tool. So what we are doing is sending all the data to a server, and that server is importing the data. In this case, for the Saudi Arabia project, we are importing like every 3 seconds with a volume resolution of 0.04 liters. So it's a huge amount of data. And the good thing about being online is that you can have multiple people analyzing the data, maybe people in the States, people in Europe, because it's online, everything is online. And it's also very flexible. I will talk about the software. And of course, this software is not really a commercial software because they're not selling it anyway. But I mean, we are open to, if somebody wants to do some study, we are open to collaborate and do something with this software. We don't really need to talk about what is end-use disaggregation and how to identify flow traces, but at the the end, when we try to identify the flow traces, we are using the basic shape of each consumption, which is based on the duration, maybe the flow rate variations, the total volume, the shape. There's like basic parameters that we use to identify which end use we are using in a specific household. But of course, this is not a perfect methodology, because at the end, what we only have 1 meter at the entrance of the house. We can measure this meter, can be a perfect meter, we can have a very high resolution, but at the end what we are seeing is the total flow rate coming into the house. If we have several consumptions that are overlapping, then we maybe have trouble identifying the different uses. And also, like for example, if you are using a faucet which has the same flow rate as another faucet, you cannot distinguish that. The same with the shower, because when we are talking about maybe the shower, we are assuming that you have like a long shower and with the more or less constant flow rate. But imagine that you have your water heater is not good. And what happens is that the temperature of the water is varying, so you are just modifying the faucet and the flow rate is changing. And also if you are a very good person, and then instead of taking a 5-minute shower, you take a 2-minute shower. How can you distinguish if the flow rate is the same, a shower from a faucet? You cannot distinguish that. So only with the flow rate is not a perfect methodology, and we have to keep it in mind that it's not 100% reliable, even if we have a very good data from the meter that we are using. I will show you some of the flow traces that we are registering in Saudi Arabia, and you will see what a nightmare they are. Sometimes, I mean, it's just guessing. There's no way of identifying anything. And this is the truth. I mean, maybe if you talk to the people of Aquacraft, they say, no, we have a very sophisticated methodology, algorithms, or whatever. But at the end, the truth is that everything you do is subject to error. Of course, we can always use support tools, like having application on your mobile phone where the user that is under study helps you in identifying. I'm putting, for example, the clothes washer now, and then I took a shower at 6 o'clock in the morning or 7 o'clock in the morning, and that can help you. But those are support tools that we have to try to help us in the identification of the uses. In the study that we are doing in Saudi Arabia, it's even worse for us, because we have to install the meter, the project meter, just downstream the roof tank. So you can imagine you have to go into the houses, cut their pipe, and install here the meter after the roof tank. And that's a really difficult project. The other thing that I want to talk about is when we are talking about the reliability of the results, at the end, this is a very expensive type of study. How much does it cost? The samples are reduced. So, first of all, how reliable the results will be. It will depend on the type of customer that we are selecting. It's very easy to say, okay, we will take a random sample. What is random? It's realistic to say that we are going to be able to have a random sample? Probably not, because to measure water consumption with such level of detail, you need the permission of the user. And starting from that, that's not really a random sample. Also, the size is very expensive, it's limited on the budget. The duration, most of the studies, if you look at the data set, they only have 2 weeks of data. Why is that? Because the logger from Aquacraft only allow for 2 weeks of data every 10 seconds. If you want it every 5 seconds, it's only 1 week. Of course, that the technology has already changed that, and we have the data set that we are getting in Saudi Arabia. It will be for 1 year, the whole year, without changing anything. So we install the data logger, and we have connected to the server. And the way we are doing it, we are measuring the water consumption every 3 seconds, and hopefully the batteries will last for over a year, 2 years. And of course, the data quality, and it has to do with the type of equipment that we are using. I've already mentioned that. So, if we talk about data quality, first of all, to talk about the meter measuring capabilities. This is the first thing, because most of the times, and probably that was the reason why I included the smart in the title of the presentation. Most people, most manufacturers, they want to sell us like electromagnetic meters. I don't know, are you familiar with the technologies of metering technologies? Do you know what an ultrasonic meter is and an electromagnetic meter is? They want to sell non-mechanical meters to do these kind of studies, because they say that they are much better, they have much better resolution, but in reality you will see that those type of meters are not useful for these kind of studies. So, if I ask you, what is this?
Car.
Yeah. What kind of car?
It's a Ferrari.
So, that's what we are doing. That's what we are doing in end use identification. You see,
I've never seen it.
this is a picture. But what I wanted to do is when we are installing a meter, depending on how much data we get from the meter, if we get like every 1 minute, every 15 minutes, every 1 second, depending on how frequently we read the meter and how well the meter can measure water consumption, we can go from this to this. Obviously, this everybody can identify. In this room, only Andrea could identify in 1 second. That was a Ferrari. There's another one. I'll see if you are
Next time, that's from car, come on.
So, what we have to worry about is about the first thing, the metrology. And most of the studies that we are thinking, if we are thinking about water saving, one of the worst things that we can have in a house is the leaks. And for example, one thing that has been mentioned in this conference, of course, is to use the utility meters. And we have to be very careful with that. Why? Because if that meter has been installed maybe 5 years ago, 4 years ago, then the starting flow rate of that meter is not high enough and is not able to register the leaks that is inside the house. If we talk about American meters, which is the maximum flow rate of an AWWA meter? It's around 20 gallons per minute. That means, in reality, if you look at the studies that I have taken from the literature, you see the maximum consumption flow rate of a typical house is usually below maybe 10 gallons per minute or even lower than that. But it means that having such a big meters in the house limits the low flow performance. And if you look, there's a study by Carfus from Utah State University, you probably know him. And if you look at the results of their study and you look at the low flow performance of the meter that they tested, you see that there is a significant number of them that were not performing, even new meters that were not performing properly. So we have to be relatively careful when we use the meters that are already installed by the utility, or at least not to get all meters, or try to get that meter that at the most has been installed like maybe 1 to 2 years, but no more than that, because otherwise you run the risk of that meter not having enough low flow sensitivity. Also with high flows. And the other parameter that is very, very, very important is the frequency response. And that's where the non-mechanical meters fail. Non-mechanical meters have two problems. These are the non-mechanical meters. These are electromagnetic from Census, this is Gabriel, and this is from Sapel. The first thing is that these non-mechanical meters, they work with batteries. And to have the problem of having batteries is that the sensor cannot be working full time. So basically, what they are doing is they are sampling the signal, the flow signal. Sampling the flow signal means that, like, for example, if we have a flow trace like this, and we are sampling every 10 seconds, means that it's measuring the flow rate here, the flow rate here, the flow rate here. So we are not getting the continuous flow trace, we are just getting the dots here. So we have like something like that. Of course, you can always raise a little bit the signal, and it will be more or less like that. If we go like, for example, every 5 seconds, then you will have something like this, where you are getting more dots. And the second problem is the frequency response. Frequency response means how fast they respond against change in flow. And you see that sometimes they are very, very slow. So maybe you open the faucet, and then it takes a while before the flow rate in the display starts going up, and then when you stop, again, the other way around, it takes a while before it stops. So they distort the flow traces. Is this important? Well, when we are talking about identifying flow shapes, that can be very, very important. Maybe in terms of volume, this will be exactly, the volume in the red area will be exactly the same as the volume in the blue area. But in terms of trying to do shape recognition, then we will have trouble. That's why we are using, at the end, what I do always recommend is use mechanical meters, and in the mechanical meters, you always use positive displacement meters. David, you were talking about having a sensor or whatever, but in the commercial side, we have like very cheap meter. The meter that we are using for the project, it costs like 30 euros, and the sensor that is giving us 0.1 liters per pulse, and it's very reliable and it has no problem, and you just fill it in there. It's another 25 euros, 30 euros. In total, 60 euros, the meter plus the sensor, just to have a resolution of 0.1 liter, and that's probably enough for most of the studies that we do. The other thing that we do, this is too much.
I can't even reply.
You know what it is.
It's really very
You know the problem I did when I was sitting there, and I should have make it a little bit bigger. But when we have the problem is with making the overlap uses. It's not only when we have this. If you mix the frequency response with the overlapping of uses, then it makes it more difficult. And of course, when you read, because I know there are many people that have worked in automatic end uses disaggregation, and they have algorithms to split overlap uses and so on. But at the end, when you mix, like for example, low frequency response with the sampling plus the distortion that the data logger is causing plus everything, at the end, it will the picture that you will analyze, it will look very, very difficult for you to understand what you are adding in that. So this is the first thing. The second thing is, okay, now I know that the best solution is to use mechanical meters with a high resolution reading, but how do I take the reading from the meter to the logger? So basically we have like three options. To use a pulse output, like the one that you are using, that maybe you can use the commercial pulses that the manufacturers can give you, and it is usually based on Hall effect sensors or inductive sensors. These are the pulse emitters from the manufacturers. They usually this one. The old ones use like reed switches, and I know, for example, there is a manufacturer in Australia. I don't know if you know them. That they prepare like positive displacement meters to have a very high resolution of 0.017 liters per pulse. And then basically they do what you are trying to do. They are inserting like a Hall effect. Well, no, they are not inserting a Hall effect. They are using an electronic reed switch, a switch also. But they say that it's a high frequency switch. This is like a mechanical switch. Is like every time the piston goes to one position, it closes a switch, and then it opens. And every time it goes like that, it's just a switch. The whole effect is that it uses the variation of the magnetic field to create the switches. This is the basic, the most, and I think the most effective way of extracting the signal from the meter. Somebody could try to convince us to use a communication protocol. But this is a problem. Why? Because communication protocols are usually battery consuming. So when you interrogate the meter, it will use a lot of battery, and they are very slow. So we will not be able to read the meter with a very high frequency. The good thing about using a protocol is that you know, usually the protocol tells you in the communication, the meter tells you the exact reading with all the numbers. In here with the pulse, they only give you a switch. It doesn't give you which is the reading, so you have to accumulate it in the logger or the software or whatever. But if you are trying to use a communication protocol, the old MBUS allow just to ask the meter every 1 second. But that was the old one, and it is a battery consuming, so you will not be able to have a logger which is powered by batteries, using a protocol to the meter. So this can be discarded. And also the other thing is to have analog output, like 0.5 volts. And the problem with this is also the same problem, is the battery consumption. So for example, if we want to measure like temperature is an analog value. So usually most sensors, if we want to measure this kind of variable, will give us this type of output. And the other thing is wire or wireless. I mean, we can have the pulse with wired or with wireless consumption. Anyway, so in this table you see the advantages or disadvantages of using like the pulse output and protocol communication. I don't know if you are planning to give all the presentations away or.
Yeah, actually this is a good one because I want
because
to
I can go faster.
presenters to, if it is possible, if you can send me your presentation and I will put them on a website. It is already there. I think on the right presentation is not there. Somebody else, maybe you, Matteo and Alessandro. Anyway,
Yeah,
yes.
well, so I'm just
send me
planning.
the presentation and I will put it on the website.
Okay, so yes, I can go faster for some other things. So basically here you have a table with the advantages and disadvantages of using the different type of communications from meter to logger. But what I'm trying to say is that that's not obvious. Okay, the other thing is the logger recording capabilities, and the first problem is the memory capacity. Not anymore, because now you can have gigabytes at the cost of 2 euros, 3 euros. So not anymore. The memory capacity is a problem. But the problem is when I'm talking about the capabilities of the logger is how do you store data? Because it's not the same storing the data as a fixed interval, like counting the number of pulses at fixed interval, like 5 seconds, 10 seconds, or whatever, or trying to record the time of occurrence of the pulses. Because if you record the time of occurrence of the pulses, basically what you can do is to calculate, like for example in our case, every 0.1 liters, which is the average flow rate of consumption of every 0.1 liter. So if you have like instead of the pulse value is 0.04, then you can have for each, if you record the time of occurrence of the pulse, you can have the average flow rate of every 0.04 liters. So you have a very nice flow trace, which is very, very nicely defined. And just to, because this is a word that I think is better just for you to see which are the results. Imagine this is the red line is the real. The flow trace that we are recording with the data logger that we have developed, in which we store the time of occurrence of the pulse. And the green line is how that flow trace will become like if we store the number of pulses every 10 seconds. And you see that the flow traces are quite significant. And you have to think that, for example, one of the parameters that you use to recognize one consumption, for example, is the flow rate. Because maybe I know that this consumption and this consumption comes from the same source because they have exactly the same flow rate, for example, from the closed washer. But if you store the data like this, maybe you think this and this come from the same source. That's why I'm saying that when we are using data sets from other sources, we have to be very careful on how this has been analyzed, especially if we are using those data sets to calibrate our models for do automatic disaggregation or automatic end-use recognition. This is another example. For example, here you see this one, the consumption stopped here, but then suddenly you open another faucet, which is different use, and then you close it, and then you have a very short consumption. If you do it every 10 seconds, can you imagine how different the flow traces are? And this difference have a real direct effect on the results that when we do the end-use disaggregation. If we, instead of going 10 seconds, we go like 1 minute or 15 minutes, I mean, it's just like guessing, like the first picture. Maybe you are lucky and then you have it right. But
well, I will, and then I will explain you how I managed to discover it was a car. But is this a real world example, or is it something you generated just to make it?
No, it's real. It's just yes, I only get from the SD file, from just a snapshot of what is being recorded. You see the flow rate, the consumption flow rate, and this belongs to my house, in fact.
And what was going on there?
To tell you the truth, this is, I think this is a shower. I say what I see. Here, because I don't remember, I just took for the example, but usually thinking of what I usually do, I usually open the one faucet just to wait for the hot water, and then I have like two shower heads, one on top and one for this, and probably this becomes for the top shower head, and maybe I just
you stop just to soak up.
Stop, and then maybe again, and then I have some adjustment in the flow rate. I live in a building in which there is a pump downstairs, and obviously you have a pressure vessel, and the pump starts when the pressure in the vessel drops below one level, and then it fills the vessel, and then there is an oscillation of pressure at the inlet of my house because of that. So that's the reason why you have like a decreasing flow rate. Here the pump is on and is filling the pressure vessel, and here it is. That's one of the things. So at the end of all the story, what I wanted to say is that we have to decide what we want to do. Maybe with this is more than enough, depending on the objective of the study, but we need to know that if we have, I mean, currently we have equipment available that allow us to do something like this. Of course, we have to choose the right equipment, but when I say we have to choose the right equipment, it doesn't mean that it's going to be much more expensive. Because probably, like choosing non-mechanical meters, like ultrasonic or electromagnetic meters, is more expensive than buying cheap mechanical positive displacement meters. So it's not, I'm not saying that this necessarily is more expensive than this. The problem is that I get this spending a lot of money if I don't do it right. So we have to select the proper equipment. So other things that we have to take is the battery duration, and this is something because, for example, in the study that we are conducting in Saudi Arabia, we are expecting to have like 1 or 2 years data set. Why? That's possible because we are compressing the file, we are like trying to optimize the type of file that we are sending to the server. So each file, even the data compression does not make any loss in terms of information. It is compressed and the files are relatively low. And the new batteries, the lithium batteries, allows for, if you connect to the server like maybe twice per day, that's probably the batteries will last for like 2 years. So we can have a much longer series just to, for example, if we want to interact with customers, for example, what we are talking about, like giving some inputs about water conservation and whatever, in this type of monitoring, we can do that. Because people usually tend to forget that they have something installed. Maybe you remember the first month or whatever, but after that, they forget. And also, if the installation of the place allows for that, we can always use rechargeable batteries plus solar panels. So it's not, that's not a problem. In fact, how much would you say a solar panel for a data logger will cost?
€2.
Sorry?
€2.
A little bit more, but like around €5. So I mean, when we think about the new technologies and we think about the equipment, it has become very, very, very cheap now. So it's possible to do development, specific hardware development that can be very cheap. And also one thing that could be very interesting, just for example, to save batteries,